Welcome class. Thank you for joining me for your 2.4 notes. We are going to continue our conversation today about lines. However, today we're going to take a look at a different form of the equation of a line. Today we're going to talk about point slope form. What point slope form is useful for is when you are given a slope and a point and asked to create an equation. So as you can see there under the does this formula look familiar section, you can see I rewrote it using some color coding. So this first y and this x, those are your input and output. So those are the variables that remain in the equation. What you are trying to do is you are plugging in a y value from a point, an x value from a point, and plugging in a slope in order to create an equation. So anything colored in that equation is a number you are plugging in, and then the black x and y's are the input and output variables that stay that create this as a true equation. So I want to dive right into your first example to show you how you can use this. Write an equation of a line that goes through 12, -8 and has a slope of -2/3. What I'm seeing here, I'm seeing an x1, y1 as a point, and I'm given a slope. So I'm going to just start plugging these in. Y minus the y value from the point, which is -8, equals the slope, -2/3, x minus the x value from the point. And I want to clean this up a little bit. I really don't like when I see subtracting a negative number. So that y minus a -8, I'm going to clean that up and call that y plus 8. And this side will remain exactly the same. The awesome thing is, this is a legitimate equation. You can actually leave your equation like this. And in fact, if it tells you to write a point slope equation, this is exactly how I want you to leave it. You don't have to solve every equation for y. Now there's another use for this type of equation. Not only can you be given a point and a slope, but you can be given 2 points. What I want you to realize about being given 2 points and being asked to do this process is you still need a slope. It's still completely necessary. However, now you actually have to be the one to discover what the slope is. So we're going to find our m. And if you recall from our last note video, slope is y2 minus y1 over x2 minus x1. So I'm going to go ahead, I'm going to do this calculation. 10 minus -2, subtracting the two y values, and now -2 minus 6, subtracting the two x values. So on top, 10 minus a -2 is the same as 10 plus 2. So I'm getting 12 on top. -2 minus 6 gives you -8. To reduce my fraction to make it a little bit nicer, you end up getting -3/2. So you may have noticed in the equation, all you're looking for is a slope and a point. Well, in this case, you actually have 2 points. So the interesting thing is, it actually doesn't matter which point you use. And I'm going to take a moment here to convince you that that is true. So I'm going to start with this first point. I'm going to create a point slope equation using the slope we just found and that point. So y minus the y value from the point, so -2, equals our slope, x minus the x value from the point. And I'm going to clean that up. Y plus 2 equals -3/2 x minus 6. And again, that is a perfectly legitimate equation of a line. If I ask you for a point slope equation, you can leave it just like that. But what about the student that wanted to use the other point for their equation? They plug in that point. Y minus the y value from the point equals the slope times x minus the x value from the point. And once again, I'm going to clean it up just a bit. to look like that. So now I have two different looking equations, but they came from the same information. So what I'm going to show you is these are actually in reality the same equation. So both of these are legitimate answers. Both of these are correct answers for the point slope form of this equation. And I'm going to show you. To show you, I'm going to solve both for y. I'm going to create two slope-intercept equations. So I'm going to distribute that negative 3 halves. Y plus 2 equals negative 3 halves x. Negative 3 halves times negative 6 is a positive 9. Then I'm going to subtract the 2 over. On this side, I'm also going to distribute the negative 3 halves. So negative 3 halves x. Negative 3 halves times 2 gives us a negative 3. Add the 10 to both sides. And look right there. Their slope-intercept forms are exactly the same. So what you should be realizing is it does not matter which point. Once you find the slope, all you have to do is choose one of the points to continue working with, and it'll get you to an answer. So for the test or any homework problems that I give you that use this form, I will provide both answers so you can check to make sure that it matches at least one of them. Because again, it could look different depending on the point that you choose. So moving right along, looking at the next one. The third type of equation of a line is standard form. So standard form, what it means is a, b, and c are all integers, and technically a should be greater than 0. So what we're looking for, example 3, we want to write it in standard form. Now, standard form, again, we're looking for everything to be an integer. So it's a little difficult to see here, so I'm going to rewrite it. Y equals 3/4 x minus 2/3. And I want to do away with the fractions. Now if I multiply both sides of my equation by 4, it would take care of that 3/4, but not the 2/3. If I multiplied by 3 on both sides, it would take care of my 2/3, but not my 3/4. So I'm trying to find something that will work for both. Something that when I multiply will get rid of the 4 and the 3. Now, you can consider that the same thing as finding the least common denominator. All right? So what goes into both 3 and 4? What works? Well, I'm going to multiply both sides of my equation by 12. If I multiply everything by 12, it'll get rid of all of the fractions. So I will get 12y 3/4 times 12. Now, again, type that into your calculator to make sure that you're doing it right. But when you take 3/4 times 12, you should get 9. 2/3 times 12. When you do that, you should get 8. All right, so we're partway there. We have all of our integers, or all of our numbers as integers. The next piece, we need x and y on the same side, and we want the x to have a positive coefficient. All right, so what that's telling me is this 9 is good where it is. It's already positive. I want the y with it. So what that means, I'm going to subtract off 12y from both sides. So that'll give me 0 equals 9x minus 12y minus 8. So I have my x and y together now. That c represents a constant. So any constant needs to be on the other side of my equation. I gather the x and y on one side, and I move the constant to the other. So now I'm going to add 8 to both sides. So I have 8 equals 9x minus 12y. And that is going to be the standard form of this equation. I have my x and y together, my constant on the other side, and everything is an integer. Our next example is going to look exactly the same way. I want to turn that into standard form. Now, I've taught you before, the first thing you should think when you see parentheses like that is I want to distribute that. So, to get this one in standard form, the first thing I'm going to do, I'm going to distribute that -2. So I'm going to get y minus 4 equals -2x plus 10. Now comes the debate. Which side do I want everything on? I need to gather my x and y together. I'm noticing here my x has a negative coefficient. It has a -2 with it. So in order for that to be positive, that's going to have to end up on the other side of my equation. So to gather my x and y together, this time I'm going to choose to move my x. So I'm going to add my 2x to both sides. So 2x plus y minus 4 equals 10. So now my x and y are together. Next step, I need to move every constant to the other side. So I'm going to add 4 to both sides. So 2x plus y equals 14. And once again, I've accomplished my mission. I have my x and y together, my constant on the other side, and I have everything as an integer. We're going to do one more example in this notes video before splitting it. So a plumber works on a job for 12 hours and gets paid $600. He works on another job and gets paid $420 for 8 hours of work. Write an equation that represents how much he gets paid based on his hours worked. And then we want to figure out how much will he get paid for a 30-hour job. So we're talking about how much he gets paid, D, is being based on the hours he worked, H. So what I'm seeing here is H is our independent variable, and it is dictating what he gets paid, what D, his daily pay is. So that's going to be how I represent this. Instead of X comma Y, it's going to be H comma D. And what I'm seeing that for 12 hours of work, he's getting paid $600. I'm also seeing that for 8 hours of work, he's getting paid $420. So essentially what they've given us here, they've given us 2 points of information. They're giving us 2 pairs of that hour and his pay. So given 2 points, this is exactly the type of situation we've already discussed. So how do we create an equation to represent this? Well, to use a point slope equation, don't forget, we need to find our slope first. Now, because it's not given, that means we actually have to find it ourselves. So I'm going to use our slope equation. And again, just to remind you, y2 minus y1 over x2 minus x1. So we're going to subtract our 2y values, 600 minus 420, and subtract our 2x values. 600 minus 420 gives us 180. 12 minus 8 gives us 4. So divide that, we get 45 as our slope. All right? So what that's telling me is he's getting paid $45 per hour, essentially. That is the rate of change, the slope. Now, we are looking for finding how much he gets paid for a 30-hour job. For that, we need an equation. So I'm now going to use that slope that I just found. And I'm going to use one of the XY pairs. I'm going to choose the one with the smaller numbers. It tends to be easier to use points that have smaller numbers. So I'm going to plug that in. Y minus y1, or the y value from the point to 420, equals the slope, which is 45, then x minus the x value from the point that we chose. So there's an equation. That's how we can represent this situation. So given the x, or in this case, I really should have used h, it's giving us y, his hourly pay, which I should have used d for. I apologize for changing the variables. So we want to know how much he gets paid for a 30-hour job. All we have to do is plug 30 in for the input and figure out how much money he gets out. So let's take a moment and calculate that, shall we? So we want to know how much he makes in 30 hours. I'm actually going to plug in 30. So y minus 420 equals 45 times 22. 45 times 22 is 990. So final step, I want to know how much he makes. I'm going to add 420 to both sides. He's going to make $1,410. So thank you for joining me for this first half of the notes video. We are going to discuss more examples and practice in class, and then on the next video, I will finish off the rest of these notes. So again, thank you for joining me. Make sure you fill all of these out, and we will discuss this more in class.